Hello, my name is Carl Scavino, and I am presenting on linear regression modeling. This topic may sound simple, but has some complexity while also being crucial to multiple aspects of analysis and statistics. The basis of this is in the correlation coefficient, which is a way to quantify how related the independent variable is to its dependent output. I have chosen to represent this with these two graphs. On the left, the dependent output has a greater variability, meaning that the left graph has a lower correlation coefficient, making the right graph a better model for predicting the output. This information helps contribute to the engineering problem of determining probabilities correlated with certain variables, which shows both possible correlations and how strong they are, and more importantly, what option to choose based off of those results. Concrete is a perfect example of how linear regression modeling can relate to the real world. Concrete is a crucial aspect of our daily lives, and so testing and figuring out where its failure point is very important. An article that I found discussed how one way to test the strength of concrete is by submerging it for 28 days under different conditions and then seeing how strong it is afterwards. One way to predict this is linear regression modeling. Knowing when concrete will fail is very important, and so this paper went out to determine which model would be best for predicting the compressive strength of concrete after this 28 days. What this paper and many others found was that linear regression modeling was not the best way to predict the dependent output. This can be shown in the graph that is taken from the report. On the right, one way that they used to model artificial neural network has a much tighter distribution than on the left. What is being compared is the measured value of the compressive strength versus the predicted value of the compressive strength. Given that linear regression modeling was not found to be the best way to predict dependent outputs, it may seem that it has no place in engineering. However, a crucial aspect of linear regression modeling is the correlation coefficient, which can quantify how closely the independent and dependent values are. This is used to measure which model is best. As I mentioned, linear regression modeling helps determine which variable is important in having a more accurate prediction of the dependent variable. Therefore, using the linear regression model to determine which model is best shows that it still has a place in engineering.